Today we would like to talk about integration testing with test containers and Go. And I'm going to show you some slides, and the second half of the talk, my colleague Erdem would show you a lot of Go code and live demo. And my name is Nikolay. So both of us, we work for Zalando, but in Helsinki office, Zalando is famous to be here in Berlin to have headquarters, but we are located in Helsinki. So we have a backend team there where we maintain about 20 microservices, and all of them are mostly in Go. And today we would like to share our experience from the user perspective of this library. We are not taking the credits for maintaining the library, even though we have some PRs, and some of them even went through to the master. But we are not taking this credit, we're just sharing our experience. So why at all we need integration test? Of course, we would like to avoid this kind of bizarre situation. Then we get 2 unit tests pass, but our system doesn't work in the way we expect it to work. And for us, the basic integration test is a test against some database. So in this case, it's Postgres database, and in our project, we use mostly Postgres database for 90% of the time. So this is the basic scenario, some Go service and testing its interaction with Postgres database. So, and then how you actually get a database for testing. Of course, you can start Postgres locally, like really starting it not in Docker. You can emulate Postgres with some in-memory lock for the testing purposes, but of course nowadays by default choice is Docker. So Docker has a lot of advantages, and especially for testing then, so you can have a 100% compatible database in your test, and even though you can use exactly the same version as you use in production, you get the same version in the test. So it's very convenient and it's more reliable, and you can always expect that database state is empty. Then you start a new container, and then your test wouldn't fail because there is some other data, maybe some corrupted data left in the database. So eventually we want to test some Go service and test its interaction with Postgres, and the Postgres runs inside Docker container. So this is the first approach, like, okay, we just do a Docker run, we run the Postgres, and that's it. Then we run our test against this Postgres inside the container. So what could go wrong? Okay, there are certain things which could go wrong. First of all, we can end up with a host port conflict because we map a port inside the Docker container to host port, which is a fixed value. And then if there is some other server, some other Postgres running on the same port for some reasons, maybe from a different service, or maybe some deployed version of service, then you get a host port conflict, and then your test cannot proceed. Another problem you might get that if your Postgres or some other database inside container is not ready yet. For example, container is there, but it takes some time to actually for the database to start and to be ready for the test. And if you start your test earlier than that, then your test would fail, and then you have to debug what's the reason why. So it will kind of annoy you all the time. Then with just invoking console command docker run, the problem that after the test, container is still there. It keeps running, and it takes your resources at your machine. So you need to come up with some mechanism which would possibly kill or stop those containers after your test is done. Okay, and another problem that if you try to reuse the same container in the future test, then you get some stale data there, so it's not empty container anymore. And if your test depends on this data, then it might be an expected behavior for the test. And of course, you need some kind of mechanism in which you would be able to start the Docker container before your test. So if you're on the local machine, of course, you can do that from console command and then run your test from IDE. But for CI, probably you need something else. So yeah, it's not so straightforward how to bind those life cycles of the container and of the test. And then you actually try to solve some of the problems, like kind of you detect if container is there, you restart it, or you reuse the same container, and then if you use a shell script, then your shell script becomes like bigger and bigger, but still some of the problems remain because we still use host port, and we use here we use a fixed sleeping timeout to be sure that Postgres is already started in the container, and we can start our test, and it's safe. So this sleep5 command is, in some occasions, it could be like we overcommit, but in some occasions, if we have high CPU usage, then it might be it's not enough, and then our test would fail again. So there should be some better way to do integration testing with Docker containers. So if we recap about Docker architecture, then actually there is on our host machine or any CI machine, these days there is a Docker daemon running, and Docker daemon exposes REST API. So then we invoke Docker run. It actually uses Docker daemon REST API under the hood. So why invoke Docker run if we can invoke REST API, and then we would be more flexible? This is example for the documentation for Docker REST API. For example, if you want to invoke a command inside the container, if you exec this command, and in this case it's date command, then actually to do that, first you need to create a command. So it's not yet running, but you just create that inside the Docker. Then the next step, you start the execution of the command, and then you start it, but it's in a sync way. You don't get the result immediately. So you kind of, next step is to inspect the result. And then you actually get the result, and maybe you get the flag that it's not, a result is not yet available. So just this kind of simple, like then we type Docker exec, then it actually at least 3 REST calls to Docker daemon. So there is TestContainers library, which actually uses this idea to use Docker daemon API directly without invoking like Docker run commands. And actually, this library exists in different flavors and different languages. So today we are showing about Go, but originally it's all started with Java, and Java is the most, these days, the version for Java is the most mature, and it has the highest community, but a version for Go is also usable, and you can get many benefits from that. So under the hood, this library uses native Docker Go client, which already exists and supported by the Docker company, provided by the Docker company. Like for Java, it's not this case because there are only community versions to interact with Docker daemon. So out of the box, this library provides you features like host port randomization. Another feature is that you get containers cleanup after your test is completed. And then there are available different waiting strategies for the container to assure that it's ready in a way you want it to be ready before you actually run the test. So the API is simple like this. There are 2 entities. One is container request, and another entity is the container itself, like container which is started. So in this case, we just want to run the latest version of Docker of Postgres, and then we want to expose a specific port of that container to the host environment. So if we run this container, then if we run this command in Go, then container gets started, and we can see that the port from that standard Postgres port from inside container get exposed to our host environment to some random port. It usually starts with 32,000 something, and then there is actually API to get the host port back by the port of container. So this is very handy because it actually prevents host port conflicts. You can run multiple different Postgres containers or any other database, and all of them would be independent. So you can also run your tests in parallel. You can get parallel builds of the same test, of the different tests, and you never get that host port conflict. So another feature which comes out of the box is containers cleanup, and it's implemented by starting a new helping container, which is called Rike. So there is Rike is a character in Japanese movies which can kill people by just knowing the name. So in the world of containers, it's not the name, but labels. So the idea is that then you start a container from test container library. Then that container gets assigned some specific labels, and then test container library opens connection to the right daemon, to the right container. It tells what are the specific labels, and then it keeps the connection open in a separate Go routine. And once your test completes, that Go routine is shut down, this connection is shut down, and then this is the trigger for the Rike actually to start acting. So it stores those labels, and once it detects that those the connection is not alive anymore, it waits for more for 10 seconds. After that, it starts to kill containers by those labels. So in this library, if you start the container, you get always a separate Rike instance running next to it, kind of sidecar. And then this library provides you out of the box different strategies. In API, you can wait for host port to be ready. You can wait for HTTP, some status, some body, some predicate for the body. You can wait for containers log to some specific string to appear there. You can, of course, implement your own custom waiting strategy for container to be ready. And there is one like there you can aggregate them into a single, like you can use like multiple as a single waiting strategy. So if you want to wait for the host port to be ready, and this is done this way, then we create a container request. We specify what waiting strategy we want. So by default, this host port has timeout of 60 seconds. And what is important, it does the check from outside of the container at the host environment, and it also checks the port inside container, because now operation systems, when you start a Docker container, your port is open at the host environment like almost immediately. So if you check just by some Linux command, if the port is open, yes, it's open immediately, but the service inside container is still starting. So it's important also to check for the port inside the container, and that the library does it for you, so you don't have to care that much about it. And this is one more example for HTTP waiting strategy. You can wait on the specific endpoint, on the specific port, and then you can wait for a specific status. And even though you can wait for the body, you can get the body response, and then you can assert if it has some specific string or not. So okay, now it's demo time. So I hand over to my colleague Erdem.
I will also get my water. Hello. Can you? OK, you can hear me now. My name is Erdem, and I work at the same place as Nikolay does. So in this demonstration, I'll have two use case scenarios, one of which will be super simple. A basic Postgres database will be started, spinned off by a container. Then we will run our test against it. After understanding the basics of how this test containers library works and how we can actually ask some different containers and how we can customize our waiting strategies, then I will go and deep dive into a bigger and arguably more complex use case. So this is the initial use case. We have a Postgres container here. Then we will have our own repository functions. Then within the same test main function, we will start and initiate everything and run everything eventually. So let's start. OK, so I hope everything is visible for you. Should I increase the font? Everything is visible? OK, no reactions. Great. So we have this user struct, which we store in our database. We have the user repo struct, which has a connection to SQL database and have three extremely difficult functions of creating and getting the users by just SQL queries. And one function to run the migrations here. I hope you can see from my head. Then let's start with the actual test. So, OK, so the test, as Nikolay showed, we will initiate a Postgres container right away from here. A container can be initiated by directly the image name, which stores at some sort of image registry. Then you can, you can either start from an image, then define the expose ports, your environment variables, and your waiting strategies. Here, I just for demonstration purposes put two different strategies and combining all of them into a multi-strategy, so waiting for every single one of them. And this waiting for listening port, we listen to our base port of 5432. Then once everything is ready, which we ask test container to do by setting this flag true, then we will have a Postgres container. Then eventually, after everything is ready, we will get the port that's mapped into our host port, then generate our URL, connect it, and run the tests with our repository stacked. But let's jump into running the. OK, for this, maybe I can first. This looks a bit small. I have this watch containers function. So this, we are just watching all the containers running with some formatting in every 2 seconds. Now, when I run the, OK, now we are there. We are about to ask for the container. And when we ask, there is no container created yet. Then we will jump into right away to this line or this line. So let's watch this. OK, they are created. As you can see, two different containers are created. The container that we asked, and it's randomly mapped into a port, this random port. And it created this Reich container as well, which is responsible for killing this after our tests are finalized. Then we will continue here, and we got the host port, which is the same thing. Then generate everything. Then let's continue. We have the connection, no errors. We ran the migrations. Then we will run the tests. Then once the tests are run and we pass all of them, we go there. OK, it hasn't been cleaned up yet, but because it takes approximately 10 seconds for Reich to believe that everything is gone. So it first kills the Postgres container, then kills itself, then everything is cleaned up. So the advantage of this has been, OK, maybe I can discuss it here, because I made a slide for this. Just with a single command of go test, we managed to run a Postgres container, mapped it to a random port without actually needing to know which ports are available, then ran our test, and everything is cleaned up afterwards. So it was as simple as just saying go test, but I clicked on debug for showing things. But what can we use this actually for more advanced use cases? So I created this second demo for end-to-end testing, where we have two services, one of which depends on the other one because of some use case. And the user service here will be a data service, basically, responsible for creating users and serving them. And the ticket service is also responsible for tickets, but it will also know about the users and users' data. So our tests are going to run an HTTP test And all of these services that you see, ticket service and user service and the Postgres actually as well, they will be all their own containers running in the same Docker network. And they will also expose some ports to the outside world, so we can actually debug and test things as well. So if you want to go to that demo, yeah. OK, let's close this as well. Perfect. So for this demo, this is a bit small. OK, we have the user service. If you quickly want to go over the user service, it's just like 38 lines. What does it do? It creates the connection to Postgres, has 3 handlers, which is one of which is just a basic health handler. The others are creating like get and post users. And let's quickly look at them as well. So there are no questions left. Read through the request body, create the user in database, and return the same user, or just get the ID, find it from the database, and just serve the database. And this is going to be run on this Docker file. And the Docker file uses a builder Docker and copies everything within the context and just runs go build and runs the application on an Alpine image. Ticket service is also as simple as this one, with one exception. It will not require a Postgres connection. It will just need the user service URL. Of course, it would also need some database, but for the sake of simplicity, I decided to have an in-memory database, which is just a sync map. So it has the user service URL. So it should know about the user service and should be able to call it within the same Docker network. So let's look at it. Tickets. You create a ticket post, then you get it. And the ticket is basically a user ID, a movie name. And when you want to get a ticket, it should also have the full user data, including the user's name. So it will fetch it from the user service. But so once we have these, let's focus on our actual tests. So in our test, we have to create them one by one, sort of, because the user service will require a Postgres container within the same Docker network. Then ticket service will require the user's internal URL. So the main test is here. For all of these to happen, we need to first create a Docker network, which we can do with this library. OK, you can see we are trying to get this network here in this get network function. If it is not there, then we create it. Then we want to have it. OK, then let's talk about this, how to handle the networks and the network aliases. So I wrote these start container functions here. So for every containers or sub-entity within our Docker network, these containers are created, and they return one internal URL, which will be used within the Docker network, and one mapped URL. That's for us to be able to debug it in more conveniently. So in addition to the previous Postgres, we here have the network name, which was created in the test main. And we provide our own network alias names. For this user service Postgres, it is user service Postgres. So it will, instead of localhost, it will have user service Postgres alias. Then here I also wrote a small for SQL waiting strategy. In addition to those pre-built library ones, you can always have your own waiting strategy. You just need to implement this function because it's just an interface, which basically holds the thread or holds that routine until you feel like it's ready. And what we did here was we just wait until select one returns something like OK, no error. We repeat it in a ticker, then as long as it returns something, then we are fine. If it doesn't return anything, then it will just return an error. OK, then we have users container starting. It says the same thing. It runs. But here, the difference is now, instead of having a pre-built image, we want it to start from the Docker file. So thankfully, the container request has such an option from Docker file. And this Docker file actually requires either the context of where Docker file is, or a context archive, which you can feed as a reader the Docker file content. And the Docker file's name, what all of us use the default Docker file name anyways. So in this case, we since this is in a different directory, just like join the directories and find the right context for this specific, then it will actually run the Docker file, build the image, and run the container, and find the right ports and return the internal URL and external URL. And maybe we can now start actually running this. Let's start with this. OK, we are there. Let's create a network as well. OK, now network should be created. OK, integration test network is there now. Now let's watch the containers again. I also created Postgres, apparently. Oh, did I not? OK, let's go to console. OK, Postgres is running. Now let's go to ticket service as well. And here. OK, now user service is running at this port. And if we click on this, they're same. Of course, there is nothing, but if you just go to health, it should return something. And where did this go? OK, it was behind actually, yes. And if we checked this, then Postgres is there, and this random thing is because it's just a Docker file without a name, so it's just random thing it generated, and user service is there. And if we go and create a ticket service as well, OK, ticket service is here, then we can test this as well, just to be sure it's there. OK, it's also running. And it's also, again, behind. So let's look at our tests. In our test, we create the user first using the user service post request. And the name of the user is Berliner. Then we assert that when we get it, it's there. Let's assert it. So the user ID is 1. So yeah, so the user is here, then the tickets will be created. Yeah, and ticket is going to be created. Then once we want to actually get the ticket, OK, we got the ticket, I guess. The got ticket should have the same user as, like, yeah, it's very hard probably for you to see, but it has the user from the user service. Yes, now it should pass everything, and once we look at this should be cleaned up. OK, everything's done. OK, so let's go back. To our presentation. What? Fantastic internet access, huh? Present.
You can show in this way, I think.
Yeah, I think I will show this way if this doesn't work. OK. Oh. Anyways, so we managed to run everything in the same Docker network and managed to actually port them as well, so we can test out ourselves. And if for some reason some of them fails, then you can go and see the Postgres, and from your favorite Postgres client, just go and check your data. And in addition to that, we actually build everything in every single time, if you make a change, of course, because Docker caches things. But if you make a change in one of the services and run something, it will be immediately reflected in this place as well. So we will actually, you can actually test it in your local without having to deploy anything. So let's go to takeaways. So this is the website to go and check. That directly goes to Java version, but under the same GitHub repository, you can see the Go version and stuff. The good part of it, the code is very easy to read. You can always contribute and see the PRs. And like, if you understand Go, you will pretty much understand everything it has. It is great for integration tests. What we call integration tests in this context is this Postgres kind of very small way that you can run as in your local very simply without actually needing any complex mapping. But you can even use this library for end-to-end testing where you have multiple servers running and you can try the full end-to-end testing in your local machine. Yes. That's all. And yeah, thank you very much.
Thank you. Do you have questions?
Yeah, if you have questions, please shoot. Doesn't work still. Yeah.
So do you have any experience with running this stuff in GitLab CI?
We don't use GitHub CI, but as long as you have a running Docker, it should be fine. You don't need anything else. Like you must just need to have a Docker server behind this. So you can probably do this in Docker.
Well, with GitLab CI, it's a bit.
Yeah, I heard that it doesn't allow to start your Docker containers. Like
Yeah, you have to give it special permissions to do that, and
Yeah.
then the networking is quite ugly. So.
in GitLab CI, it might be tricky, but I was running that successfully on Jenkins in the previous company, and in Zalando we have our own CI, and it doesn't limit us not to start containers from the test.
Talk, by the way. So I have
you.
one question regarding the integration test.
Yes.
If you're going to test multiple entities, for example, the tickets and users, every entity will going to initialize a new Docker for Postgres.
If you need, then yes. Like you can do this, or you can use the same Postgres if you are willing to. It's all up to you. You can configure in this way that you initialize a single Postgres, then map the same URLs to every single service you have as an environment variable, and they will run their own migrations in different databases. So you can optimize it this way. I just wanted to show everything in a very direct and straightforward way, so it's like the Go way.
Thank you.
Thank you.
Is it possible to even run the tests inside a container, or to define an image where the tests run in a CI environment or something?
I have not tried this, but I see no reason not to. You just probably, again, need to handle your networks in the right way. And
but it's nothing test container provides, so you should...
Oh, yeah, of course. If you want to run your tests in a different container, then you just have to create a new container running these tests, and you can do this. Did I understand the question correctly? Maybe not.
Can I try also to answer? I think, yes, you can do that, but yeah, I don't see like much purpose to do that, because if you try to debug it locally, then I think this approach gives you more like drawbacks than because then you need like your test has to be in the same Docker network. Like if you're not, like if you don't want to use host ports, then it has to be the same Docker network. And how you do it, like if you debug tests from IDE, it's more difficult in this way, I think. But yeah, nothing prevents you to do that.
Hi. Thank you for the talk. Do you have a way to get the logs of a crashed container? Because if your container, I mean, if you only have Postgres, it's simple. But if you have like 5 containers and one of them crashes and is removed immediately, you don't get the crash logs.
Yes. I think in Java library, it's very easy to see all the logs. And this Go version of the library is like relatively new. So I think it's one of the plans to add more logs of the actual port, direct every single line of log within the containers to outside world. So we can actually see everything, but right now it's not possible. I think if you can make that PR, we can review all together.
Just a remark regarding GitLab CI. You can make it work if you make the Docker and Docker work. There are ways to it, but it's not trivial. But it's supported.
Yeah, I can add to your question that you can configure like to expose the log from some directory from inside container to your host machine, and then you would get them there. It's one thing, and another thing that, yes, in Java library, you can configure that the logs are streamed like from each container inside your test, but it's not yet there. I saw recently on Twitter that they started discussion actually to add this functionality to Go version of the library.
So thanks for the presentation.
Sure.
Just a question regarding the like creating the database, for example. I understand that your example was like a very straightforward example, just to let us know how it works. But I would like to understand how you guys manage like an application that has different packages, and usually you have like multiple layers in this package. For example, you have like 2 repositories inside these 2 different packages. How do you manage to create, for example, this database just once, or do you usually create one database per package?
So if I understood the question correctly, you're asking if we have a single Postgres container, then how we manage to run the migrations and create different databases for every single service. Is it the question? No? Then maybe I didn't understand. Package meaning services, I guess? Yes. Yes.
And so you have package A and B, and inside this package you have like 2 different business logics. So
Oh, yeah, I see.
you have
Okay.
2 repositories,
Cool,
right?
yes.
And these 2 repositories that rely on this database. So do you create like one database for each package inside like this package to have an integration test? Or
Yes. That would be my preferred way. Yes. So you can run the same. So for every single package, you can have the test. And if your package requires some Postgres integration, then in the test main, you initialize this. But thankfully, you can run these in parallel, so it doesn't take that much time. That was one of the advantages, actually, that you can create different Postgres at the same time because the post conflicts and they are like totally isolated. So that would be my preferred way, yes.
Thanks for talk. You think it's okay to mix environment information and test? From my point of view, it's some kind of complex.
Environments.
You mixed info about environment, about Docker containers. It's a rather huge block of code.
Yes.
And only after that you run your integration tests. It is not easy to read, for instance.
The way that I am used to is that we always pass the variables as environment variables anyways. So you don't have to change your main service for the testing. So if your service requires the Postgres URL and all kind of settings and configurations as environment variables, then within the test, yes, it will take longer lines to write this inside your test. But I think it's better than changing your own service for the sake of tests. So the service is clean, but the tests are, yes, a bit more cumbersome instead of the other way around.
Okay.
Yeah, that's, yeah.
I can add to this question that like you can extract that code somewhere to like a common library where you start the Postgres, like then at least this part of code goes away. Of course, for your like HTTP service, you need to customize that to provide some URLs, and yeah, that could be a lot of code. But on the other hand, it's Go code. It's not some Bash, or it's not some Docker Compose, not JSON, not YAML. It's Go code, which you used to work with. And then for the Java version, they have some kind of ready baked like classes in Java, which can start like Postgres. Like you don't need to provide your kind of custom waiting strategy. It's already there. So instead of using some generic container, you use like Postgres container, and it's like one line of code. In Go version, it's not yet there, and probably it's not going to be there. There is some discussion in community about that. Yeah, but you can organize your code so so your test looks cleaner. Like you can separate that by putting different files, different packages probably.
And, one more point. Is it okay that you start too much containers for each integration test? Tests become rather expensive and runs long enough, I think.
Yeah, but integration tests, what we call integration tests, is checking a single service interaction with databases, and usually it's not more than 3, I would say. The maximum we get Postgres, Elasticsearch, and Redis. Maybe that Atlassian, how is it called? Local stack for emulating AWS, so it would be 4 at maximum, and that's not that expensive even for local machine. And for CI environment, which usually has more CPU and memory, that's fine.
Yeah.
Those like end-to-end tests, depending on how many services you have, yeah, they might be expensive. And especially in Java world they are, because for each service, a Java service usually starts much longer than Go service. So for Go, it's also not a big issue because they start quite fastly and they don't consume that much memory comparing to Java. Okay, any more questions? Okay.
Okay, thank you very much.
Thank you very much.